Hi everyone and welcome to this session on AWS Fargate, a serverless compute engine for running containers that works with both AWS container orchestrators, the Elastic Container Service, as well as the Elastic Kubernetes Service. My name is Radu Dobrinescu. I'm a partner solutions architect here at Amazon Web Services. And prior to AWS, I have worked in roles in consulting and solutions architecture, mostly in the enterprise software environment. In my current role, I work with partners and help them develop solid AWS practices, as well as help them to create new and innovative solutions for our joint customers. I'm always excited to hear about how container services are being used and how new applications and solutions are being developed on top of serverless offerings, and also to see how different organizations can transform themselves by implementing DevOps practices. So I'm always happy to discuss and chat about any of these topics as well as anything AWS partner related. Please feel free to reach out to me on email. Let's start with a brief but at the same time comprehensive definition of Fargate. And I said in the beginning that Fargate is a serverless compute engine for containers. So what does that mean exactly? Well, it's serverless because there are no servers to manage. All the servers, all the EC2 instances are managed by AWS, so you don't need to worry about scaling, patching, securing those instances. Also, you don't need to worry about an AMI or an Amazon machine image. You don't need to maintain it, update it, or harden that image as it is being managed by AWS. And it's a compute engine because, well, that's where the containers are running. So all your containers, you don't need to manage the compute layer itself, you only need to manage the container definition. You don't actually interact directly with this compute layer. Before moving on to see how exactly this works, let's see some of the benefits that Fargate customers leverage. Well, first of all, they get to deploy and manage only the application, not the infrastructure. Fargate removes the operational overhead of scaling, patching, securing, and managing servers. And in terms of monitoring, you can actually gather metrics and logs using open source tools like the AWS distribution of the Open Telemetry project and send this to various destinations. Or you can leverage the built-in integration with AWS CloudWatch Container Insights. In terms of security, because Fargate follows a workload isolation model by design, your security posture is improved. Amazon ECS tasks and Amazon EKS pods will run in their own dedicated runtime environment by design. Also, Fargate will scale the compute to closely match the specified resource requirements. So with Fargate, there is no over-provisioning and paying for additional servers that are not being used. You will always pay for what you use. In addition, you can even improve cost optimization by using Fargate Spot and leveraging compute savings plans. As is the case with any containerized workload in AWS, one of the first choices you'll have to make is the container orchestrator. It's a decision that will deeply influence the rest of the choices that you will make on the road. So one of the most common requests that we hear for our customers is, help me decide which container service to use. And we recommend most of the teams to begin by selecting a container solution with the attributes most aligned to their application requirements and their operational preferences. With Elastic Container Service, customers get a highly scalable, highly performance container management service that supports Docker runtime, Docker containers, and also allows them to easily run applications on a managed cluster. And that is without setting up or configuring a control plane. So it's quite simple, yet very powerful. With Kubernetes, the complexity is a little bit higher. So you do need to create a control plane and you do need to manage the Kubernetes resources. But you get to leverage all the flexibility and the extensive functionality of the open source Kubernetes ecosystem. Both services support a broad array of compute options, have deep integration with other AWS services, and they do provide the global scale and reliability you've come to expect from AWS. In fact, if we look at the complete container services landscape in AWS, this is not limited to the two orchestrators. Beyond the management layer, you also need to consider the hosting layer or the data plane, That is, where are the containers actually running? And you can run containers on top of EC2 instances or on top of a serverless offering, such as AWS Fargate. Beyond that, whenever we are talking about container workloads, you also need to consider some additional capabilities, such as where are you storing and how you are managing your container images. And you can actually create private or public repositories by using the Amazon Elastic Container Registry in AWS. We can also consider a service mesh capability with AWS App Mesh, an offering that gives you application-level networking to make it easy for your services to communicate with each other across multiple types of compute infrastructure, such as Fargate, EC2, and covers ECS and EKS. You can also think about AWS Cloud Map if you are looking for an offering for a discovery service for cloud resources. In fact, what Fargate allows you to do is to make your application serverless. So your applications that run on Kubernetes can become truly serverless. And we see that teams coming from both largest enterprises as well as smaller companies born in the cloud do want fully managed services because they abstract the underlying infrastructure. What the teams want is to see their ability to develop and deliver new technology products as a critical differentiator. And they want fully managed services that enable to build without requiring them to hire or to train staff for infrastructure management skills. At the same time, with Fargate, you can bring your existing code and applications and simply run them. You don't need to modify any of your manifest files. And Fargate is also HIPAA eligible and ISO, PCI, and SOC compliant. So you can confidently run any critical production applications on top of Fargate. Let's have a closer look at the choices customers have for the EKS data plane across a spectrum between full control of the infrastructure and convenience of offloading the infrastructure management to AWS by using Fargate. We've seen that there are basically two choices, EC2 or Fargate. In fact, with EC2, there are also two choices. Customers can use either self-managed, also called unmanaged node groups, and these are actually EC2 instances that are completely managed by customers. So that means that the AMI falls into the customer's responsibility as well as the instance's lifecycle. With managed node groups, customers will get added automation that will automate the provisioning and lifecycle management of the nodes. That means that, for example, node updates and terminations will automatically drain the nodes to ensure that the application will stay available. Also, the EC2 autoscaling group that is behind any node group is managed by AWS in the case of the managed node groups. And one thing to remember is that at the same time, in the same EKS cluster, you can have any combination of self-managed, managed, or Fargate compute options. Let's see some practical differences between these options. So if you look at side-by-side Fargate, managed nodes and unmanaged nodes, and if you consider the units of work, basically with Fargate, you only need to consider the pod as a unit of work, and you only work and interact with the pod definition from a Kubernetes point of view. Whereas with the managed or unmanaged nodes, besides the pod definition, you also have to configure the EC2 instance and to consider it. The unit of charge in the case of Fargate is the pod, whereas with the managed nodes, the unit of charge is the EC2 instances underneath. So whether you are running any pods on that instance or not, you will still pay for the instance itself. In terms of the host lifecycle and AMI, that simply does not exist in the case of Fargate because there is no visible host to interact with. With managed nodes, you get some additional automation. That means that the lifecycle is fully managed by AWS, although you do get SSH access if needed. And also in the case of the managed nodes, AWS will give you container optimized AMI images. In the case of unmanaged nodes, you get full control. That means that you as a customer will control the lifecycle of the instance, so you will need to drain those nodes and restart them accordingly when you update or you want to terminate nodes, as well as you will need to maintain the AMI image. One of the key differentiators is how the pods are mapped to the hosts in the case of Fargate and the nodes, worker nodes. When we are using Fargate, each pod will have its own host or its own Kubernetes node. So it's a one-to-one mapping between a pod and the worker node. Whereas when we are talking about EC2 instances, whether managed or unmanaged, we typically have multiple pods running on a single EC2 instance. So it's a one-to-many relationship. And let's have a look at exactly what happens behind the scenes when we are firing up Fargate. As I said, you don't need to make any modifications to your pod definitions in order to have them run on Fargate. And how it works? First, you need to have a Fargate profile defined in your Amazon EKS cluster. A profile will include a name, a cluster name, that is the EKS cluster that it's attached to, a pod execution role, and this role will be inherited by any pod running on this Fargate profile, as well as the subnets. So these can only be private subnets in your EKS cluster. And then you have to specify selectors. Selectors are typically a namespace and then an optional series of labels that you can set on your pods. In this case, we can see that our selectors are a combination of namespace with the value prod and a label with the key stack and the value blue. So let's assume that we are creating now a new pod. We are telling this pod, we are creating it under the namespace prod, and we are specifying the labels stack and blue. Now, when we are calling the Kubernetes API server to run this pod, a webhook will intercept this request and will actually match it against the Fargate profile. If the selectors are matching, so if the namespace and the labels that we've set on the profile will match the ones that the pod definition has, then the pod definition will be augmented by some additional labels, such as the profile, and that is mapping with the name of the Fargate profile we have created, and we have a match, and also the scheduler name, which is now Fargate scheduler, since we know that we do have a Fargate profile matching this pod definition. Now, the API request is being sent to the Fargate schedule, which will actually call the AWS APIs in order to create a Fargate node and to run that pod in this Fargate node. If there is a pod that does not match the selectors, then EKS will continue to provision that node on typical EC2 worker nodes. So, what are some considerations that you need to be aware of when you are considering Fargate running with EKS? Well, there are some things that you no longer need to do, such as managing worker nodes. You simply don't need to worry about worker nodes anymore. You also don't need to pay for unused capacity because every Kubernetes node will be matched exactly with the pod resources. And you also do not need to configure, manage, and monitor the Kubernetes cluster autoscaler. There are also some things that you get out of the box. Remember, I said in this presentation that the security posture is improved. And because each pod will run in its own micro VM, you also get the VM isolation at the pod level, which definitely improves your security posture. That also gives you pod level billing, which can be very beneficial, especially in the multi-tenant scenarios, because that allows for a very easy chargeback. But there are also limitations that you need to be aware of. So first of all, please remember that daemon sets are not supported on Fargate. If you don't need this sort of capability, you should consider running sidecar deployments. Just as well, you cannot use classic load balancers. So if you use network load balancers, you can only use them with IP targets. So that means for layer 4 load balancing, IP targets only. You can use layer 7 load balancing with AWS application load balancers. So these are fully integrated with Fargate and supported. We will actually demo it after the slide deck. You cannot use privileged containers on Fargate. They are not supported. And just as well, if you are considering stateful workloads with Fargate, you need to be aware that EBS, so the Elastic Block Storage, is not supported with Fargate. You can only use EFS, that is the Elastic File System, or the shared file system over NFS offering that we have in AWS. And one more thing, remember that pods running on Fargate are only supported on private subnets. So let's summarize some of the benefits that customers of AWS Fargate will get. Well, first of all, they can focus the engineering effort on the higher value add activities rather than the undifferentiated heavy lifting of managing infrastructure. Also, AWS Fargate is focused on security because you have the VM isolation level for your pods and you also get the routinely patched environment always up to date. You do get a flexible and powering wide array of use cases, scenarios, and workloads for which you can use Fargate, and you can always improve your costs by either deploying Fargate Spot or leveraging the compute savings plans to optimize the value for your infrastructure. The compute savings plans will cover Fargate, serverless compute like Lambda, as well as EC2 instances. Cool. So let's have a look at how Fargate works with an EKS cluster. Okay, so let's move on to the demo part. And for this demo, I've opened the AWS console and accessed the EKS service page. And I do have this very basic EKS cluster that I've just provisioned in the EU West 1 region. So this is a default cluster. Basically, the only thing that is here is a node group, an initial node group made out of 3 nodes. And for the configuration part, there is an OpenID Connect provider configured for this cluster. And this will be useful when we install the application load balancer controller. So there's nothing else special with this cluster. It's just a very default cluster right after creating it. So now let's initiate our demo. And basically the demo is made up of 2 steps. First of all, we will install the application load balancer controller in order to provision application load balancers in AWS and to front-end our application. The second step would be to create a Fargate profile and a deployment to run on Fargate nodes. So let's get started. And first of all, I just want to make sure that my utilities are configured and I can see my cluster, as I said, in EU West 1. And just as well, I want to make sure that kubectl is configured and I should see the 3 nodes from my managed node group, but nothing else. Okay, so now I can start configuring it. So first of all, I will need to create an IAM service account. An IAM service account allows you to basically map an IAM role from AWS to a service account in Kubernetes. That means that all the pods that will have that service account will be granted access or certain privileges that are granted through the mapped IAM role. In this case, we will be creating a service account for the AWS load balancer controller. And the policy is the AWS load balancer controller IAM policy. Now, I already have this policy and a role that the policy is attached to in my account. If you don't have that in your accounts, you will have to create them. So basically, that means that the AWS load balancer controller, which will actually run as a deployment in Kubernetes, will be granted privileges in order to create new load balancers in AWS, to create target groups, and to map those to services in Kubernetes. This is done via CloudFormation. And once it's done under CloudFormation, we will be seeing a stack coming from EKS CTL and the name of the IAM service account. Okay, so now we can check that the service account is created in Kubernetes, and we can see that it's there and it's available for our pods. Nice. So now what we can do is to actually install the load balancer controller. For that, we'll be using Helm. So I just want to make sure that we have the EKS repo configured, and then we can install the controller. So basically what we'll do is Helm install, the name of the deployment from the repo under kube system namespace. Our cluster name is set up. The service account, we won't have to create it because we've already created it, so we just set the name for it, the AWS load balancer controller. Oops. Okay, so now we see that this has been successfully created, but we do want to actually check that everything is up and running. So we'll do a rollout status deployment, and we see the deployment for that is successfully rolled out. So now that means that we do have the AWS load balancer controller. That means that whenever we create a ingress object or resource in Kubernetes, this controller will automatically provision an application load balancer, so a layer 7 load balancer in AWS. And based on the ingress configuration, we'll also create the target groups and target groups binding. We'll cover that in a second. Let's now move on to Fargate. So with Fargate, first of all, we'll have to create a Fargate profile. And we can do that from the AWS console or with EKS CTL. And I'm using EKS CTL now to switch back to the console. And basically it's quite simple. Create a Fargate profile. We have to specify the cluster, the name of the profile itself, and then we have to specify at least one selector and at the minimum the namespace. Optionally, we can also provide additional labels as selectors. For this one, we'll just keep it very basic, namespace, and whatever pod will run in this namespace, game 2048, because it matches the selector of the Fargate profile, that pod will be scheduled on a Fargate node. Now, if we want to have more logic here, again, we can add optional labels and we can set different matching and selectors criteria in order to, let's say, split certain pods and have certain pods that only have certain labels run on Fargate and maybe different Fargate profiles as well. So once the Fargate profile is created, you will want to actually check it, and let's wait for it to be completed. Right, so now that it's completed, what we want to do is to actually check the Fargate profile as well. So we can do that with EKSCTL get Fargate profile. And since we have just one in this cluster, we don't even have to specify the name of the Fargate profile itself. What's interesting here, so we can see the selectors, it's just the namespace. As we've described, the Fargate profile gets a resource name. And then we see that basically you also have some subnets. And we didn't specify any subnets when we created the profile. But EKS is smart enough to identify the private subnets from the configuration of the cluster itself, and then attach these private subnets to Fargate. Keep in mind, if you do not have private subnets for your EKS cluster, then the Fargate profile creation will fail, right? Because Fargate only supports private subnets. Okay, so now that we have everything ready and the Fargate profile is also ready, what we can do is have a look at the sample deployment. And basically this will be the 2048 game. So for this one, we'll create a separate namespace, and the namespace where we deploy the application will obviously have to match the namespace that we provided in the Fargate profile, because we want this application to run on Fargate nodes. We'll give the, so we'll create the namespace and then we'll create a deployment. We'll give the deployment a name. And we do have some sort of metadata. And then basically we need to specify the container. So the, let's say, actual application. And we see that these containers will be listening on port 80. We then create a service. So this is a basic service of type node port. So it will basically, on every host, every Fargate host, it will expose the container over a port on that node. you'll see that we don't actually use this service to access the application. What we will be using is the ingress resource. So we will be creating an ingress and basically have a bunch of annotations which will actually invoke that AWS load balancer controller. And we do that by setting up the ingress class, which is ALB, and we are mentioning that this is an internet-facing load balancer, and also the target IP, the target type, which is IP. And basically, with Fargate, this is the only target type that it is supported. So this would typically be IP or instance mode. With Fargate, IP is the only option, and we'll see in a minute why. And then we have, because this is an application load balancer, so a layer 7 load balancer, we do have some path routing rules, but this is very basic. Actually, we are just using all the paths and directing them to the service 2048 service port 80. So once we have that, let's actually create this deployment, apply, and there is a warning here. That's because we are out of v1 beta 1, and basically we should be using v1 for the ingress. That's fine unless you are on v1 22 or plus. I'm on v1 21. So let's actually check the status. I think we should see in the deployment here we have 5 replicas. So let's see if all replicas are up and running. So we'll have to give it a second. Right, so now the deployment has been successfully rolled out. And one interesting thing that we can do is actually to check now the, well, actually before that, let's actually check the nodes that we have on this cluster. So if we do a kubectl get nodes, we used to have 3 nodes out of the managed node group. And right now we see that we have 5 additional nodes. Right? So remember that we said in Fargate we have a one-to-one matching between pods and nodes. And that's why, because we had the replica set to 5 for this deployment, basically we have 5 pods which are running themselves on their own node. Even more, if we have a look at the pods themselves, we can see that the IP of the pod is actually the IP address of the node itself, so of the micro VM that Fargate provisions. Right, so you don't have to manage any secondary IP addresses, additional ENIs or anything. The IP address of the pod is the same as the IP address of the Fargate node. And that's basically the reason why we have the target group and the target type set to IP address rather than instance type in the load balancer. So now one more thing that we can do is to actually check that ingress. So let's see. So it should be ingress 2048 under this namespace, and we can see that it has been created. And because it takes a while until the load balancer is provisioned, let's actually switch back to the console and have a look at what has been created on that side. So now, if we go into this in the console and check the EKS cluster, we can see a new Fargate profile being created, and we can see obviously the subnets, the private subnets where the pods will be running. There's a pod execution role actually allowing the pod to execute some actions on the AWS APIs on your behalf. And then we have the pod selectors, and basically we just have the namespace. We don't have any other labels set up as selectors here. I just wanted to have a look at the load balancer. So we go into the EC2 management console, and we'll check out load balancers. And we should be seeing that a new application load balancer is being provisioned for us. So let's have a look as well at the target group as well. And basically this target group right now should have the 5 instances, so the 5 pods, right? And again, if we have a look, we will see that these are the exact IP addresses of the Fargate nodes. So the load balancer will put this data directly in the IP address of the pod, so you don't have to go through an extra hop by accessing the node port service and then from that service to the pod itself. This is the case when you are using, for example, EC2 instances and you are running multiple pods on that instance, each of the pods being actually mapped to a port on the instance through the node port type of service. Okay, so since we have that up and running, let's get back to the terminal and actually test out our application. And we can do that by getting the ingress URL. And let's check out if everything has been provisioned and whether we can play the game. And we see that now it's up and running. So now you've seen how easy it is to actually provision your applications on Fargate, and basically you are offloaded of the task of management, operating, patching any of your instances. There are some prerequisites though. You need to enable the OIDC provider, and that is because you need to use the IAM role to service account mapping. You need to create an IAM service account for your AWS load balancer controller. You need to install this controller using Helm, but all these are pretty straightforward and you can run them with a few EKS commands. Once they are set up, then you don't need to do anything else. And then you are moving to the actual applications. You do need to create a Fargate profile, which is basically a series of selectors, whether it's a very simple one, just a namespace, or whether it's a combination of namespace and labels acting as selectors for your application. And then you can just deploy your applications on Fargate, making sure that the metadata that you set on the application matches the selector on the Fargate profile. Whenever it matches, then the Fargate scheduler will schedule those pods to run on Fargate nodes. I included also links to the official documentation for installing the load balancer, as well as to the EKS workshop, which will guide you through this sort of demo that I just run, and giving you all the commands to run Fargate. Thank you very much for your participation, and I hope this has been useful for you. Thanks, and have a good day ahead.